All right, welcome back, everybody. This is Mrs. Agapov. This is page 5 of your team review packet that you received on Friday. I hope everyone is doing well. Just so if you aren't familiar with the setup of these, so I will go into just the quick answers of each of these questions, and then that will take about 3 to 4 minutes, and then I'll go into a direct, deeper instruction of my process on how I got my answers and why I did what I did. So if you're looking for just quick answers, stay tuned, and if you want a more direct instruction, like lecture type of situation, I will also be providing that as well at the end. All right, so without further ado, let's get into the video. All right, so the standard is 8E44, 8EE4, preform operations with numbers expressed in scientific notation, including problems where both decimal and scientific notation are used. All right, so let's dig into this first problem. And again, like I said, I'm just going to go over the quick answers to them versus the process that I did. So if you check your answers for this one, you should have 7 times 10 to the 5th power over 7 times 10 to the 4th power, resulting in 1 times 10 to the 1st equals 10. And your written explanation should be Woodland Park Zoo. I've never been there, by the way, y'all. I've never been to Woodland Park Zoo. How sad is that? I've lived in Seattle for so long, and I've never been. Okay, I digress. Sorry. Woodland Park Zoo is 10 times larger, or Woodland Park Zoo receives. See, I started thinking about the fact that I've never been there, and I totally forgot what I was doing. Woodland Park Zoo receives 10 times more visitors than Islandwood. Is that a place? I don't know. Visitors. Is that a zoo here? Never heard that. Islandwood. Someone tell me on Tuesday or something. That'd be cool. Alright, so Woodland Park Zoo receives 10 times more visitors than Islandwood. So this is your direct answer for 5A. Alright, 5B. Your answer for this one, you could have written it in scientific notation, which would be 3.344 times 10 to the 1st, or you could have had it in standard form as 33.44. Answer here, again, could be scientific or standard. For scientific, you would have had 6.251 times 10 to the 0, or 6.251. 5D. Your answer here, scientific, would be 1.049 times 10 to the 6th power, or you could have had scientific or standard form as 1,040,000. That's what I meant. 1,040,000. 1,040,000. All right, and 5E, standard notation, let's mix it up a bit, would be 21,740. See, I got that one right. Spoke it well. That's not proper English, guys. Don't repeat that. All right, and you'd have 2.174 times 10 to the 4th power. There you go. So those are your quick answers for this page. Let's scroll up to the top part so we can dive into the process and how I got my answers a little bit more in detail. Okay, so if you were tuning out now, you're leaving me. Thank you. I am glad that you tuned in long enough to get a review and get your answers. Until next time, I'll see you later. All right, for the rest of you, let's dive into 5A. So, first we got to read it. The website for Woodland Park Zoo receives 7 times 10 to the 5th power visitors per year. The website for Islandwood receives 7 times 10 to the 4th power visitors per year. Determine how many times more visitors per year the Woodland Park Zoo receives than Islandwood. So first off, we want some key information here. We know that Woodland Park Zoo receives 7 times 10 to the 5th power visitors per year. And according to Islandwood, receives 7 times 4 to the 7 times 10 to the 4th power per visitors per year. And the main question here is asking how many times more visitors per year does Woodland Park Zoo get than Islandwood? So first, I can see that automatically comes to mind is how many times more. This sentence right here tells me that I'm going to use division. Now, it may not seem like that's a no-brainer or that's not that obvious, but if I asked you how many times does 6 go into 12, you would automatically think 12 divided by 6, and you'd get 2. How many times bigger is 12 than 6? You'd go, well, it's 2 because 6 plus 6 is 12. There's 2 6s here. That means that you can multiply 2 by 6 to get 12. So 6 is 2 times smaller than 12. Or you could say that 12, why isn't it writing? Okay, 12 is 2 times bigger than 6. Okay, so we have that little bit of a reference point here. So I want to know how many times does Islandwood's visitors go into the total amount of visitors for Woodland Park Zoo. So I can write 7 times 10 to the 5th over 7 times 10 to the 4th. So there's multiple approaches that you could do. You could do the standard exponent rule, subtract, and then divide. And what I mean by that is divide 7 by 7, getting 1 times 10. 5 minus 4 is 1, giving you 1 times 10, or 10. So there's that approach. Or you could actually put these in expanded form and then divide. So 7 times 10 to the 5th power is 700,000 divided by 70,000. And if you just plug that into your calculator, you'll get 10. Which means that Woodland Park Zoo has 10 times more visitors than Islandwood. Gives you 10. Because when we think times, this word times, we literally mean multiplication. So if I did 70,000 times 10, I would get 700,000. You can double check that, put it into your calculator. If you're like, Miss A, I don't trust you. I don't believe you. I trust me. All right, I'm moving on. So this page, there's so many different ways that you can really go about answering these. But if you want a more step-by-step situation, you're like, I don't really care that there's a different ways of doing this. I just want you to tell me one way of doing it. Here's one way of doing it. So for 7b, 8.36 times 10 to the 3rd divided by 2.5 times 10 to the 2nd. The first way that you can do, what you want to do, your very first step is to divide the d values. And if you tuned into my prior video for page 4, the d values are this number here. So remember, scientific notation is 7 times 10 to the nth power. This is the d value here. So to divide the d values, so by doing that, you'd have 8.36 divided by 2.5. That gives us 3.344. All right, so your second step, so this was your first step, and your second step will be to subtract the exponents. Okay, so if we had 10 to the third over 10 to the second, which is what we had at the top right here. 10 to the third over 10 to the second. That's where I got it. Okay. You can subtract them, getting you 10 to the first. So you could do 10, 3 minus 2 equals 10 to the first. Or you can also see this as 10 to the third is the same thing as 1,000 over 100. Cross cancel your zeros and you'd end up with 10 over 1, which is the same thing as that right there. So all in all, what you end up having, put this in a different color, what you end up having is 3.344 times 10 to the first power, which in standard form is the same thing as 33.44. So there you go. There's a little bit of explanation. So if you want, you could probably put these two steps, this divide the d value and subtract the exponents, on your toolkit. That might be a good thing to put on there. 5C. So 5C, instead of dividing, we are multiplying. So there's one way of doing it. So first, what you could do is put both of these into scientific form. So let's do that. I'm going to rewrite 6.58 times 10 to the negative 3 times, putting this into scientific form, move this decimal over, creating a d value that's less than 10 but equal or greater than 1, 9.5 times 10 to the second power. Okay, so what you do here is you group your d values and you group your base 10s. So you would multiply 6.58 by 9.5 and then have your 10 to the negative 3 and your 10 to the second power. So you will multiply these together, resulting in 62.51. So 62.51, that's this right here, times, so instead of subtracting, what you're going to do here is do 10 negative 3 plus 2. So you add your exponents, okay? And in doing so, you end up with 62.51 times 10 to the negative, or to the negative 1 power. Now, you're not entirely in scientific notation. Well, you're not entirely, you're not in scientific notation. In doing so, you have to move the exponent over to the left, which increases the exponent by plus 1. Negative 1 plus 1 is actually 0, so you end up with 6.251 times 10 to the 0 power, which is the same thing as 6.521 times 1, or 6.251. Okay. So first off, I want to kind of revert back here. Like, why are we adding the exponents here? So let's use a different color. Let's highlight this area. Like, why are we adding the exponents here? So exponents, by definition, exponents are repeated multiplication. And if you asked anybody in my class, I'd be like, exponents are repeated what class? And everybody would say multiplication. I think I annoyed them saying that, but oh well. So it's repeated multiplication, so that means that we would have 10 to the negative 3 3 times. Now, this is tricky because negative 3 is 10 to the negative 3 is actually a fraction. Anything to the negative power class is a fraction, everyone would say. So this would be 1 times 10, 1 over 10, and then 1 over 10 times 10 times 10. So what you end up here is, so 100 over 1,000 equals, if you put that into your handy dandy calculator, 100 divided by 1,000 gives you, dropping stuff, gives you 0.1. So we can do the reverse here. So whenever we see 1, if we wanted to put this into scientific notation, we'd move this over 1, meaning this would be 1 times 10 to the negative 1, because we're moving this to the right. You can see kind of like how we reverted back. That's where we're getting this 10 to the negative 1 right here. That's where we got that from. Okay, so that may be a little bit more than in-depth explanation than you were anticipating, but that's that. That's how we get our negative first power. That's why we end up adding them together, because we have 1 times 1 times 1 times 10 times 10, which ultimately gives us 100, and then this right here is 1000. 100 divided by 1000 gives us 0.1, okay, or 1/10 of a value. 1/10 is equal to 10 to the negative 1. Alright, so I'm actually going to skip 5D and go into 5E. I feel like this one's a little bit more important. So we have 3.03 times 10 to the 4th minus 8,560. So this one here, you're like, whoa, hold the phone. We have two different forms here. We have something in scientific notation and we have something in standard form. So you have two options. You can either convert this 3.03 times 10 to the 4th power into standard form, or you can convert 8,560 into scientific notation. And then add, and then group, and then keep the exponents the same, so on and so forth. My preferred method for this is actually to convert 3.03 times 10 to the 4th into standard form. So to do that, we need to move our decimal place back, or we need to count the number of decimal places based on this 4 up here. So we have 303. I have 1, 2, 3 decimal places already, so I need one more. Minus, no, I need 2 more. Sorry, I need 2 more. Learn to count, Miss A. 1, 2, 3, 4. There we go. Minus 8,560. So we have 30,300 minus 8,560. And when we subtract that, we end up with 21,740. And like I said, that was our standard form, or we can get really fancy and get a level 4 and put this into scientific notation and put 2.174 times 10 to the 4th power. And we get that 4th power by counting the 1, 2, 3, 4 decimal places. Okay, so I'm actually going to stop at this strategy here, mainly because I feel like it's the most efficient and the least troublesome. Trying to move the decimals around, it gets really complicated and really messy really fast, so if I show you my little notes over here, yeah, not pretty. So let's just keep it to this example, this strategy here for success. And I believe we're done. Yep, woo, all right. You've finished page 5 of the interim, or sorry, the review packet. Thank you so much for tuning in with me tonight. I hope you have a wonderful rest of your day. Thanks again. See you next time.